So the next problem on the agenda for review is problem 37. And it simply states that assume that you have a mass of 50 kilograms and Earth has a mass of 5.97 times 10 to the 24th kilograms, and the radius of Earth is 6.38 times 10 to the 6th meters. What is the force of gravitational attraction between you and the Earth? So what it's basically saying, once again, is just like the problem in 33, that what's the gravitational attraction between two objects? So once again, we're using the force formula. Force equals G m1 m2 over r squared. So G, as we've been stating over and over, is 6.67 times 10 to negative 11th newtons meters squared, kilograms squared. Our mass 1 is 50 kilograms, which is stating that's ours. And a lot of times you might see the book write big M with an E because that's mass of Earth. A lot of times with the planetary bodies, they use the capital M because they're so large. It's not important one way or another. I just want you to be aware when they use it. So the mass of Earth, they actually gave you in the problem 5.97 times 10 to the 24th kilograms. So we have our two masses. Now we just need the distance between them and the radius. They also gave you, without having to look up, 6.38 times 10 to the 6th meters. So that being said, once we have that information, now it's just simply a plug-in formula. So F equals, well, G, 6.67 times 10 to the negative 11th Newton meters squared, kilograms squared. Mass 1 is 50 kilograms. Mass 2 is 5.97 times 10 to the 24th kilograms, all over the radius, which is 6.38 times 10 to the 6th meters squared. And as we know, the kilograms up here will cancel out this kilograms down here. The meters down here, once it's squared, will cancel out this. Our answer's in newtons. We're moving in the right direction. Doing the math, it's going to take you to about 489 newtons, give or take. I'm using the book's answer at the moment, so you might be plus or minus, so don't worry about that. Just make sure that you're getting around that number, which will mean that you are putting into the calculator correctly. But please be careful. Practice, practice, practice. The last part of this problem in B, it's actually saying, what is your weight? Well, if you're understanding, shouldn't the force of gravitational attraction also be the force of weight? And if you're assuming that, you are correct. But this is actually calculated just like we've been doing. Force equals mass times the acceleration due to gravity on the planet. So if we're doing that, we take our mass, which is 50 kilograms. And since we are on Earth, we're going to use negative 9.8 meters per second squared. If you don't use the negative, it is understood that weight is in the negative direction. But when we do that math, we end up getting 490 newtons, which, if you look, that is basically equivalent. And it's showing you that the attraction due to gravity, the acceleration due to gravity, is the same force, just calculated in different ways. So that is question 37.